So for our first example here, we're going to be delving into the controversial world of NBA three-pointers, and we're going to be looking at LeBron James, who makes about 37% of his three-point shots in 2017-2018. We're going to be comparing that to Steph Curry, who in 2017-2018 made about 42% of his three-pointers. So, to begin, we'll focus on LeBron here, and we can see he makes 37, so the question becomes, if he shoots 10, what are the chances he makes half of them? That is based on this. If LeBron took 10 shots in one game and he made half of them, should we be surprised or not? What's the probability that happens? And in order to do this, we need to first of all realize it's binomial. Well, he has two options. He either makes it or he doesn't. And that one is independent of the other. And it's actually been shown for NBA players that making or missing a shot or a free throw doesn't actually really impact their ability to miss or make the next one. So it's independent, two options, we're good with binomial. So for our first step here, we'll go ahead and we'll list our information. We'll list X, N, and P. Now we want to keep track of the chances he actually makes half of them. And so P is going to be the probability that he makes the three-pointer. That's 0.37. Next thing we need to do is fill in N. This is a total number he's shooting, which is 10. And then X will be how many of those 10 do we actually expect him, or are we trying to count on him making, and that's half. So half of 10 will be 5. The next thing I'll do is I'll go ahead and on step 2, write out my formula. This is the probability that the number he makes, big X, is equal to 5. To fill this in here, I'm going to go ahead and write it out as N, choose X, times P to the X, times 1 minus P to the N minus X, and I'm going to fill the individual parts in. So here I have, he has total of 10 shots. I'm choosing 5 of them to make. I'm going to multiply that by the probability he makes one, which will be 0.37, and I'll take that to the X power, which is 5. I'll then multiply this by 1 minus P, 0.37, to the N minus X power. And I'm going to go ahead and simplify it so we can talk about it. This will be 10, choosing a combination of 5, times 0.37 to the 5th power, times 0.63 to the 5th power as well. Now, this part right here makes sense because there's a 37% chance he makes it. And we want him to make 5, which is why we have 37% to the 5th power. This one over here makes sense because he has a 63% chance of missing, and we want him to miss 5 of them, which is why I have 63% to the 5th power. This right here tells me how many different ways this could happen. So I have the number of ways it could happen times probability he makes 5 times the probability he misses 5 of them as well. When we go to plug this in, we can plug in using the combination button on our calculator, or we can go ahead and actually write it out. That is, our formula for a combination is n factorial over n minus x factorial times x factorial. So this is yet another way we can write it out. So plugging this in then and keeping 4 decimal places because it's a probability, I get 0.1734. Which tells me there's a 17.34% chance, it looks like, that if he shoots 10 three-pointers, that he actually makes half